Hey guys, we're working on surface area and volume of spheres, and actually it's spheres and hemispheres today. So it says, just to get started, the intersection of a plane and a sphere. So think a sphere is really just going to be like a ball, if you want to think of it like that. So like this blue figure here is my sphere, and it's a 3D figure, so it's like all of the space that's inside that ball would be the volume, but it's the whole ball, okay? And then a plane is just like a flat surface. So like this is just showing if the plane intersects that sphere at a point, it just barely touches it. If that plane intersects the circle or the sphere at any point, not through the center, then it just creates this circular shape right here. And why we talk about this is this idea of the great circle. So like if I have a plane that really like slices my sphere in half or cuts through the center, we get this circle right here, which is called the great circle. Okay, the great circle is important because it's going to give us some information about the sphere. It says when a plane intersects a sphere so that it contains the center of the sphere, it divides the sphere into two congruent hemispheres. Okay, so a hemisphere, if you want to think of that, it's like half of a sphere. And one thing that's kind of unique about it is it does include this great circle, but it also has this like flat circle as the base, and then that cone, or not that cone, excuse me, that rounded shape right there. So that would be our hemisphere. It does include that base. Okay. So as we work through here, two formulas. So surface area of a sphere is the first one that we use, and surface area of a sphere is just 4 pi r squared. So pi r squared is like how I find the area of a circle, but the surface area is 4 pi r squared. And then the next question would be, what is the surface area of a hemisphere? So really think surface area is anything that you can touch on that figure. So when we talk about the hemisphere, a lot of times I'll have students that'll just say, oh, it's just half of the sphere, so it's 2 pi r squared. But that's not actually quite right, okay? So if I think here, 2 pi r squared would be anything that I can touch on this space here. That would be my 2 pi r squared. Wow, pen's not working. 2 pi r squared. But one thing that a hemisphere has that the sphere doesn't is this circular base. So how do I find the area of that base? Well, that base is really just a circle. So area of a circle would be pi r squared. So if I have 2 pi r squared plus a pi r squared for that base, what do I actually end up with? The surface area of the sphere is actually going to be 3 pi r squared, and that's the formula that we're going to be using for the surface area of the hemisphere, excuse me. Okay, so the next one says, find the surface area of a hemisphere with a radius of 3.8 inches. Okay, so hemisphere, we said we are going to use, for surface area, we use 3 pi r squared. So not a very difficult problem, we just need to know the formula. So 3 pi times 3.8 squared. Okay, and I just get on my calculator and calculate 3 pi, 3.8 squared. I end up with 136 let's go to the nearest tenth, 136.1 inches. Now, since I'm talking area, it should be inches squared. Okay, the next one says, find the surface area of a sphere given a great circle with an area of 907. Now, think about this. The last page we said the great circle is just a circle that contains the center. So if they're giving us, if I wanted to find the area of the great circle, well, it's really just a circle, right? So area of a circle is pi r squared. Now, if they want us to find the surface area of a sphere, think surface area is really 4 pi r squared. Now, we already know that pi r squared is equal to 907. So here I'm just going to take 4 times the 907, and that'll give me my total surface area. End up with 3,628 centimeters squared. So this one was actually a little bit nicer because they gave us that pi r squared. Okay, one more example on this page. Let's see if I can get it. It says, find the surface area of a ball with a circumference of 24 inches to determine how much leather is needed to make the ball. Okay, so if I'm thinking surface area of a ball, that's going to be the surface area of a sphere, which is our 4 pi r squared. Now, they give me circumference here. So what I'm missing is the radius. So think about circumference. Circumference is either 2 pi r, or I can say circumference is equal to pi times diameter. Okay, so what I'm going to do is I'm going to take that 24 and I'm going to plug it in. I like to use pi times diameter. So I go 24 for the circumference is equal to pi d. If I divide by pi on both sides, I'm going to get the diameter is approximately, so 24 divided by pi, I got approximately 7.64. So how would I find the radius from there? Well, the radius is half of the diameter. So if I take 7.64 and I divide by 2, I end up with 3.82 for my radius. And from here, it's pretty easy peasy. All I need to do is go 4 pi times that radius, which is 3.82 squared. Okay, so 4 pi times 3.82 squared is going to be 183.4 let's see here, inches squared. And there's our surface area. Okay, from here we're going to actually move on to volume. Okay, so to find the volume, we have two new formulas. Volume of a sphere is going to be 4/3 pi r cubed, I believe. 4/3 pi r cubed. Now, one thing that I really want to point out here is that it is pi r cubed. A lot of times I'll get students that'll use pi r squared, and that gives them wrong answers, obviously, okay? But 4/3 I like to put in parentheses and then multiply times pi r cubed. It is cubed, okay? So like for this example, I would say 4/3 times pi times the radius, which is 8, and then I need to go 8 cubed. On your calculator, you might see a little symbol that looks like that. It's called a caret. That means it's going to take this number right here up to the exponent. So that's what you need to look for on your calculator, 8 to the 3rd. Okay, so if I calculate 4/3 pi times 8 cubed, I end up with 2,144.7 centimeters. Volume, once again, is centimeters cubed. Okay, they'll give us a formula for volume of a hemisphere, and this one this one I do just cut in half. I'm cutting the space inside of that sphere in half for my hemisphere. So it's 2/3 pi r cubed is what I'm given. Okay, so 2/3 pi r cubed. Just cutting it in half. Okay, so here's our practice with the volume of the hemisphere. It says, find the volume of each sphere or hemisphere, round to the nearest tenth. So this first one says a hemisphere with a radius of 6 meters. Okay, volume of a hemisphere, oops, need to grab my pen again. Volume of a hemisphere is 2/3 pi r cubed. So my radius is just 6, and then I cube it, okay? So if I plug it into my calculator, 2/3 pi times 6 to the 3rd, I end up with 452.4 meters cubed. And there's the volume of my hemisphere. Okay, next example problem. Find the volume of a sphere with a great circle circumference of 18 pi. Now, this is kind of like that last piece. They're giving us the circumference is 18 pi. So I need to use my volume or my formula for circumference. Circumference, I like to use pi d. Okay, I'm going to take that 18 pi and plug it in for the circumference. So I'm going to say 18 pi is equal to pi times d. And if I divide by pi on both sides, what's going to happen? Pi's cancel. The diameter is 8, but for this, or excuse me, the diameter is 9. Wow, Olson. Diameter is 9. But for this example, I really want the radius. So to find the radius, I cut it in half. My radius is 4.5. And now I can just calculate volume of that sphere, 4/3 pi r, which is 4.5 cubed. And now I just need to plug it in. 4/3 pi, radius is 4.5 to the power of 3. I ended up with 381.7 centimeters cubed. And there's my total volume. All right. One last piece. find the volume if I'm given a surface area of the sphere as 784 pi square inches. Okay, so go back and think surface area of the sphere. Surface area is equal to 4 pi r squared. The surface area of the sphere is the 784 pi. So I'm going to plug that in for surface area. So I'm going to say 784 pi, is equal to 4 pi r squared. I want to figure out what the radius is. I could really divide by 4 pi if I want to. What happens? 4 pi's cancel. The pi's cancel out. So if I just take 784 and I divide by 4, I end up with 196 is equal to the radius squared. From here, I take the square root, and I'm going to find the radius to be 14. And now I'm ready to rock my volume. Okay, volume of a sphere is 4/3 pi radius, which we found to be 14, and then cubed. So this is going to be a very large number. 4/3 pi 14 cubed gives me 11,494.04, so I could leave it here, inches cubed. Okay, for today, you guys have a workbook assignment. It's going to be workbook pages 159 to 160. Okay, workbook pages 159, 160. Try and show some work on it. I know a lot of it is going to be calculation, but you should be able to at least show me your formula. And then just a heads up, if you're still listening to me, I will offer this question right here, this closing problem, as extra credit if you want to turn it in to me. Just include your answer to this problem in the email. You can work it out on this workbook assignment on the page 160 if you want to leave it on there for me. Okay, hope you guys are having a great day. I'll talk to you later. Email me if you have any questions. Bye.